Welcome. Thank you for having me, Vitaly. This is an incredible group, and it's great to be out among the people again. Today, I'm going to talk to you about the good, the bad, the web components. I've trapped you. You have a mystery talk about web components. Get excited. Who's a fan of component-based development? Oh yeah, everybody. All right. So you're going to love this talk. I can already tell. Components, reusable piece of UI. I mean, that's kind of it. Components control their structure, their appearance, their behavior. Here's a nice example. We love this component. It is a button. Hooray. Does anyone recognize this syntax? Yeah, all right, great. It's from a well-known library called Vercel.js. You might be familiar with it. And components have kind of won the day, right? There's a ton of different component frameworks and libraries and utilities that exist. There's a lot of sort of competing ways to do it. And web components is kind of another way. It's sort of built into the platform. You get it for free. You don't have to have any third-party code. And we'll kind of go into the benefits and the downfalls of web components, main criticisms, and so you'll kind of know how to complain about web components on the internet at the end of this talk. Just a little bit about me before we get started. My name is Zach. I've sort of been in the industry for a long time. I started my career in 2006. I started blogging in about 2007, and if anybody wants to buy my blog, it's available for $50 billion US. You can purchase that. And then in 2017, I started the 11D static site generator. Has anybody used 11D? All right, great, a couple people. I worked at LFI, and now I am at Cloud Cannon. Hooray! And I've done a few Smashing conferences before. And as Vitaly mentioned, most of those talks were about web fonts. So if you're interested in web fonts, you can check out my website for all of the materials on that. So web components. Who here has used a web component before? Okay, a fair number of folks. Wow, that's a lot more than I expected. That's great. So most developers are social creatures, right? We do what everyone else is doing. So in this portion of the talk, I, as one of your peers, is going to convince you to use web components by showing you a variety of existing examples and a variety of companies and logos. People love logos that will convince you to use them in your projects moving forward. Now, the main sort of bread and butter of web components right now is in design systems. And the reason is that web components are, again, part of the platform. You get them for free. And it's really a way to create a portable component with very little dependencies. And Microsoft has a very well-known design system that uses web components. Another one from VMware. Google has one. Material Design has web component exports. IBM has one. You might be recognizing some of these logos, right? Salesforce, Nordhealth, which is my personal favorite because they use 11D for their website, but I'm a little biased. It's fine. GitHub uses web components quite a bit. And Adobe actually brought Photoshop to the web using web components around the lit wrapper. So lit is a lightweight wrapper on top of web components. And so are web components a thing? Yes, they absolutely. Look at these logos, incredible. We've all bought into this. Look at all of those. I mean, wow, just amazing. And Google Chrome actually publishes statistics on how many page loads use web components and the web components APIs. And as of August of this year, it's up to almost 20% of page loads in Chrome have used a web component. So they're pretty popular. Just for comparison, the loading attribute for lazy loading images is at 15%. CSS Grid is at 20%. So web components, by all measures, are a pretty successful specification. And a lot of these existing utilities and frameworks around component-based development have really bought into web components as well. Many of them have options to compile to a web component. So yeah, most of them, 7 out of 10 listed here, if you don't count the one in the corner, have an option to compile to web components, which is great. So, okay, we're now convinced that web components are amazing, but what are they? So we'll go back to our beloved example, the counter component. I believe that Jessalyn had an example of this in her talk yesterday. We have a very simple component. You click on the button, and it increments to the next number. That's just an incredible example of code. And this is what the markup might look for this. So we have embedded a button inside of our my counter element. We just put that right into the HTML as a child. And this is sometimes called light DOM. Some people call it light DOM. I like to just call it HTML. I don't know why we need a new thing to a new name for a thing that already exists. But if you want to add behavior or JavaScript or interactivity to the component, you need to use something called custom elements. And you can do this using the custom element registry. So to define our myCounter element, we just use custom elements.define. We pass it the tag name, and then we pass a class, and we can assign behavior inside of that class. Now, one of the limitations of web components and the custom element registry is that you can't define a component that doesn't have a slash. And that's sort of a forward-thinking mechanism to protect against collisions from custom elements colliding with future additions to the HTML specification. So we couldn't define a custom element that's just hi, for example. So we'll want to add a magical dash in the middle there, and then it will work. Incredible. Another limitation of custom elements is that you can't define a void element or a self-closing element. So you might be familiar with image. You don't need a closing element for image. You can't define that style of element using the custom elements registry. You need a starting and ending tag. But here's the syntax of what it might look like to add interactivity to that web component. We can use the connected callback method, which is just a standard in the class definition here. And then we can just add or select our button element, since it's part of the child of our component. And then we add a click listener. We parse it and we increment it. Not much to it. And really the sort of the magical part for this, for me, is that you don't have to select any elements. You don't have to sort of find the my counters on the page and initialize them manually. All of that is done for you automatically. On page load, if you load in additional content later, it's all handled for you. You don't have to hydrate things manually. One of the things that I like to do when I'm evaluating just utilities and frameworks in general is to look at how they load before JavaScript and how they load after JavaScript. And this is really a way to focus on the performance of your page. And so when it comes to this style of component, where everything is just embedded into the HTML as children, it matches up perfectly. The before.js rendering is exact same dimensions and layout as the after.js rendering, because the only thing we've done is add an event listener. We haven't modified the HTML. So this really very simple example of a web component that uses a custom element where all the HTML is sort of nested inside, by all intents and purposes, is server rendered, right? It has 0 dependencies. We didn't have to load any library code for this. It uses progressive enhancement. There's no layout shift, because, again, the dimensions of the component before and after JavaScript match. And so I've used this to great effect in quite a few different examples of web components that are available. You can use these today. I have one called Details Utils, where it adds a click-to-close event for a details element. So when you open a details element, you click outside of it, it will close the details element. So it's just like an additional behavior that's layered on top of an existing HTML element. I have another one called Video Radio Star, which is, I don't know, maybe a weird reference that most of y'all aren't familiar with, but it will make a video element autoplay only when it's visible. So if you have a video element lower on your page hierarchy, it won't autoplay until the user scrolls to it, which I think is pretty useful. So I'm adding additional behavior on top of existing HTML elements. Another one is islands. Who's familiar with islands architecture? couple folks. It's just a way of sort of spicily, lazy loading components. So you put things in an island that you want to load in a deferred way, and here's a web component that will do that. So any web components inside of this isLand web component will only be initialized. It will only run that initialization code when it's visible to the end user. And there's a couple of different mechanisms to do this. Folks that have used Astro are probably familiar with islands architecture. You can do one where it's on idle, which uses on-request idle callback. There's a couple of other ones. On media, you can use this to do prefers reduced motion if you want to disable motion and not initialize components if the user has opted into reducing motion on their machine. You can use save data as well. There's a bunch of different mechanisms that you can use. And again, it doesn't need any knowledge of the components that are inside or nested inside of itself. You can put any components in there. In any conditions, you can mix and match those as you want. And so this, again, this level 1 custom element registry method is really ideal for adding behavior to existing HTML. But the downside here is that there's a lot of repetition when you're authoring these components. So I have to put a button element inside of each one of these instances so that it will be progressively enhanced. It will be available without JavaScript, which I don't necessarily want to do while I'm authoring. I want this to show up in the HTML that gets delivered to the end user, but I don't want to write that every time. So one of the things I don't like about this is that I really have to repeat myself over and over and over again. I did not click that at the right time. It's fine. So this is what I want to author, really. I don't want to repeat myself and write that button element into every single instance in my application, because if I make changes to that, I would have to go back and make changes to every single instance, which is not a good authoring experience. So we'll graduate from level 1 custom elements to level 2 web components using Shadow DOM. Now, Shadow DOM is a way to encapsulate and reuse a template that gets reused on all the instances of the component. So here's just a simple example of that. We have 3 instances of our counter component. We have a template that contains the markup that we want to be repeated throughout each instance. And then in our registration, or in our custom element registry, we can attach that template as part of the shadow root. So the blurred out text here, or the grayed out text here, is stuff that we've already seen, and the new code is highlighted here. So we just clone the template and attach the content. The unfortunate problem here is that this mechanism of using Shadow DOM requires JavaScript. And depending on where you put the JavaScript in your HTML, the script tag in your HTML, that can have serious performance implications for how your components render. If you put JavaScript very late in your waterfall, it can cause a layout shift, it can cause a flash of unstyled content, which is not great. But we do get the full benefits of not having to repeat everything throughout our application. All the slotted content, the child content here, gets inserted into the slot element automatically for us by the browser, which is great. And so I kind of like to think of Shadow DOM as kind of ideal for third-party widgets or things that are less important to the primary use case of the page. So things like advertisements, maybe an embed for YouTube. Maybe if people are still embedding Twitter, I don't think that is even a thing that exists anymore. But yeah, if you're still doing sort of social media embeds, I think this is maybe a good way to do it. I would just please ask folks to stop loading the full React library in their third-party embeds if anyone's working on those. Just please, please, please. Web components are kind of perfect for this, or just at least use Preact. Stop making everyone load React for the third-party code that gets embedded. And so if we look at our before and after JavaScript experience here, you can kind of see that the worst case scenario here is that we have layout shift. We only have the fallback HTML, which is not a button. It's just a number 1 text node. And it doesn't match up, so you get layout shift. So Shadow DOM, our level 2 mechanism for web components, is all client rendered. It still has no dependencies, which is great. It has full encapsulation. We don't have to repeat our child markup throughout all of our instances. But again, there's a risk of layout shift. There's risk of a flash of unstyled content. And so the main way people work around this is to put their JavaScript into the critical rendering path to prevent layout shift, to prevent a flash of unstyled content, which is, I don't know, kind of sad. There are better ways to do it. So there is a :defined pseudoclass that you can use, and this will evaluate as true when the element is registered in the custom element registry. So when the JavaScript runs, when our myCounter has been registered, then this pseudoclass will swap to true. So you can use this for progressive enhancement. Now, unfortunately, existing implementations of web components in the wild have really relied on this to hide components as another way to prevent layout shift, to prevent the flash of unstyled content. But I would warn that using this in your CSS is a JavaScript dependency. It will not swap to true, it will not evaluate as true without that JavaScript running. So I won't name any names here, but this is one of the examples that I showed at the beginning. One of the logos that I showed at the beginning was using this. And here's another one. Just kind of does the same thing. It swaps the opacity of the elements once they become defined. So I would not recommend doing this because, again, it creates a JavaScript dependency on your content. And I like to get JavaScript out of the critical rendering path as much as possible so my pages can load as quickly and as speedily to as many people as possible. So Shadow DOM, it's fine for third-party widgets, but don't use it for the primary content on your page. You're not doing that, right? You're not doing that, right? So to work around this limitation, browsers have worked on a mechanism called Declarative Shadow DOM. So we can embed our template, our shadow root, right inside of our component instance. And some of you may already see the limitation here, but bear with me. You can put your template as a child of the counter instance, and the browser without JavaScript will reuse that template and insert your child element into the slot, which is great. It reduces that JavaScript dependency. We have the before JavaScript and the after JavaScript experience matches up. We can avoid layout shift. We can avoid the flash of unstyled content. Now, unfortunately, it isn't supported in Firefox yet. So it will come eventually, but Firefox requires a polyfill. You don't need to understand this code. This is just the polyfill that you need to use to make it work in Firefox. So Firefox does have a JavaScript dependency, so keep that in mind. But it's a very small polyfill. And that is what it is for now. But when you get into multiple instances of this declarative Shadow DOM model, you have to repeat the template in every instance. So we get into the same problem that we had in the very first example, where we have to, in the authoring experience, we're responsible for this markup just in every single component that we've used in our application. So this next level of web components is great because it can be server rendered. It does, again, still has no dependencies. It has full encapsulation, but there's lots of repetition. We get progressive enhancement because the templates are reused for us automatically. And we don't have layout shift. Great. But it still has that limitation of repeating those templates inside of your code. Now, advocates of Shadow DOM will say that the main reason that we want to use Shadow DOM moving forward is that we want scoped CSS. This is a great benefit that you can get. Any style elements that you embed inside of this template will not leak out. So just as an example here, I have a component definition with a style block, and every element inside of this component will have text color blue. And no other elements on the page will have text color blue, just inside of my component instance. And that works with JavaScript-based Shadow DOM too. But when it comes to declarative Shadow DOM, do I want to repeat that style block inside of every single component instance? No, I don't. That would be a terrible authoring experience. So we kind of have this showdown right now between don't repeat yourself, DRY, and SSR. Do I have to choose between them? And in the middle of this showdown is really JavaScript. The elephant in the room is JavaScript here. So how do we work around this? Again, let's graduate to the next level and go to server-side rendering. How do we solve server-side rendering without repetition? Now, the best ideas are still sort of in motion on this, but there is an existing specification called Declarative Custom Elements, where you can embed your template definition inside of your page, and it will declaratively use that. Now, this is not real code. Don't use this. It won't work. But if you want to follow the discussion, you can follow it on GitHub there. There's a bunch of active discussion on it. And if you want to influence the future of web components and the specification, yeah, check out that URL. But the unfortunate problem here is that a good developer experience for server-side rendering is not really solved by the platform. And I think this is an intentional stepping stone. We're sort of farming this problem out to our component frameworks at this point. I think eventually we'll get there, but it's not quite there yet. And so we need another layer of abstraction on top of web components to work. Now, historically, you might have heard a lot of criticisms of web components as a competition to existing JavaScript frameworks. And I really don't think that that is the case. Web components are a lower level utility, and they can work great with JavaScript frameworks if the frameworks utilize them correctly. So they can be best friends. Let's be best friends. And there's kind of 4 different quadrants of component frameworks that exist today. There's sort of some that are trying to pretend like web components don't exist. There are some that, again, will compile to web components, which is great. There's lit and stencil in the top right corner there that have first party. They are web component frameworks. So they support SSR. But they really kind of come at it from a JavaScript first perspective, a client-side JavaScript first perspective. And there's sort of another camp that's sort of cropping up now. And I, just full disclosure, work on WebC, so that's the library I am sort of talking about. But there's another one that exists called Enhance, and you can check them out at enhance.dev. And if you want to check out the interoperability question and how different frameworks, your existing frameworks that you use today, interop with web components and web component specification, you can check out Custom Elements everywhere. There is one library right now that does not pass tests. All the other frameworks listed there have perfect scores. Unfortunately, React is still waiting to ship, and I'm not holding my breath that it will at this point. So again, there are 2 frameworks libraries that exist right now that will do server-side rendering first, web components, and I hope that there will be more moving forward. I don't want one framework to win. So if you want to make one, now is a great time to do that. And if you want to check out the ones that exist, there's enhance.dev, and then there's the one that I work on called WebC. And I'll just have a super quick WebC example here at the end to show you how it works. So in this example, on the left side, we have our component instances. We have our page template. And on the right side, we have a different file, which is our component definition. And it just has a template with a shadow root. And we only author it in one place. And WebC will compile this code to this HTML. So we still have the same repetition, but the authoring is much different. We still have the same output code, but the authoring is much different. And there's kind of two different ways to do it in WebC. You can use Shadow DOM if you want. You can use Declarative Shadow DOM if you want. But WebC can also do a Svelte-style compile, which doesn't use Shadow DOM at all. And you can kind of see that it will compile to this style of HTML. So we have sort of a generated CSS class that allows you to hook into all of your CSS instances. And yeah, we have sort of a compiled, scoped CSS mechanism as well. But it's all HTML-based. There's no JavaScript that outputs as part of this. So there's no JavaScript served to the end user for this example. So in WebC, I'm just going to give you the full checklist of the thing that I built as, yeah, just a humble brag here. But it's server rendered, with the exception of Firefox for declarative Shadow DOM. There's no library dependencies that need to be downloaded by the end user. You get full encapsulation. All your code doesn't leak out to other component instances. You don't have to repeat anything during the authoring experience. You have full progressive enhancement, no layout shift. And so if you want to try out WebC, there's a starter project here. And if you want to go and click this button, every time you click that button on GitHub, open source developer gets their wings. But the thing I want to drive home right now is that if you can do it in HTML, do it in HTML. If you can serve code to the end user that it works and renders correctly in HTML, and you can give a full featured experience in HTML, that is the speediest and most accessible way to do it. And if you can't, layer on CSS after that, and then layer on JavaScript. We don't need to put JavaScript in the critical rendering path for every single type of component. And that's kind of just a web performance primer, and that's sort of basic standards-based development. Thank you.
Now, thank you so much, Zach. Please join me for a short conversation. We have some questions. JavaScript, huh?
This is a low couch.
How are you feeling, Zach?
I am delighted.
You are?
Yeah.
That's good to hear.
I'm not nervous at all. That's fine.
Serious questions. Well, I have prepared a couple. I think one thing that I hear a lot when I'm dealing or kind of working with companies, they feel like web components, yeah, but, you know, learning curve, and then, well, we are using React at this point, and has such a huge ecosystem.
Yeah.
Whatever we need, we can just pull it in, and we can get it done quickly. Web components, yeah, but so how do we change that?
Yeah, I mean, there's a lot of history to that question. I feel like React, in many ways, went through this JavaScript-first mentality. And that was because it was sort of developed originally for single-page applications. And I think web components sort of went through the same phenomenon for a while, where they were trying to emulate React's success as part of the platform. I see the temptation there. But I think it's a real missed opportunity that we're just now trying to correct. And we're trying to make web components and component-based development be a markup-driven thing. And that will be better for performance and experiences across the board. And really, JavaScript should be an additional layer that can be added on later. And so if we can avoid that sort of pitfall and get a better default for folks, then web components will be an attractive alternative. And the problem is that people are bought into a component framework sort of wholesale for their entire application. There are a lot of extra baggage that comes with that. And I think that Astro has been incredibly valuable in changing the conversation around what is necessary for developing applications. Yep. And so I think that the pendulum is swinging back the other way right now, and I think that web components certainly can capture that if the platform can move quickly enough.
Right.
But we'll see what happens.
Well, on the other side, when we're actually looking at Next.js, we're looking at React. There is, of course, this pendulum kind of trying to find its path, I guess, this kind of bringing React to the server and then doing just what you need on the server, doing just what you need on the client, and kind of trying to mix this. So it seems like this is getting more complex, and I fear that many people who are just jumping in, at least this is how I feel very often, they're just very frustrated by how complex it is. Like you want to build an application, sure, but then I would assume that if somebody would start off with web components, it would just feel a little bit more natural if you know HTML to kind of get there, right?
Yeah.
But then many teams are kind of already in this space where they invested quite a lot of effort in this code base, which is relying
very
on
complex tool chains.
Yeah,
yes.
exactly.
Yeah, it's I think it's an ecosystem problem, right? We've sort of started with complex tool chains as a way to educate beginners, and I think that is a big mistake. And we're sort of starting to see it play out right now. But it's another consideration of complexity in a way almost drives up salaries. So it's hard to, the more complex it is, the harder the job is. It's very easy to buy into complexity because you can get paid more if it's seen as a harder problem.
Yeah.
But I think that there's a much better middle ground that we can reach that makes web development more approachable. And I think the sticking as close to the platform is the way to do that.
I also think that there are a couple of myths around web components. One of them is being that React being such a big project at scale that it's heavily optimized in so many different ways. And so I think that there are a couple of articles that I stumbled upon just recently published actually that web components are slower, the development takes way more time than writing in React or writing in Vue and so on. Is there truth to that, or where are we there?
Yeah, so if you come to it with, everybody's got their existing frame of reference that they approach the problem. And so if you've started with React where everything is a component and I want to componentize every single section of my page, then, I think there's probably some truth to that. If you layer client-side JavaScript into every single component on the page, then yes, so it's going to be slower no matter what you use. I think that the thing that I keep coming back to and the thing that I keep checking every time React releases a new version or Next.js comes out with a new version is what is the baseline JavaScript experience for a hello world? So I'll install the library, I'll bring up the network panel in Chrome, and every time it's growing larger and larger. There's no client-side interactivity to the hello world, but there's 200 kilobytes of JavaScript loaded for this page. And so when your framework sets the minimum bar of JavaScript for your application to 200 kilobytes, you're already starting at a disadvantage when it comes to web performance. So I don't think server components is going to change that either, unfortunately.
Christian is wondering, as of today, do you think that web components can be used for more complex components like a toolbar, modal dialogues? Because you mentioned third-party tools that we want to bring in, embeds, widgets, and so on. Do you see them coming in on a bigger scale for the good old-fashioned UI components?
Yeah, I think the best example of that is Photoshop on the web, right? Photoshop is an incredibly complex application, and yeah, that was built using web components. Now, I, in my personal development life, have implemented a very prominent masthead component using web components, and it performs great. It works great. So having a web component in your critical rendering path, because a masthead component is a very primary part of the page, it's very primary real estate. And web components worked great for that.
Okay. Also a question about WebC coming from Sasha. WebC seems to conclude the circle with what we already have with PHP, with SSR, being the thing again. Why not simply use what we already have? It kind of feels like we are reinventing the wheel. 100%. Okay, that was a quick answer.
Yep. If PHP is working for you, use it. I feel like it's again, it comes back to what is the code that's downloaded by the end user? What is the user experience? If PHP allows you to develop and deliver a user experience that's great, use it. The baseline of a PHP application, the JavaScript based on the client JavaScript baseline for a PHP-based application is 0 kilobyte client-side JavaScript by default. So that's, to me, a better performance default than a Next.js application.
Then I have to be devil's advocate. How are we feeling about jQuery then?
Again, jQuery is a progressive enhancement. It doesn't require you to, it doesn't sort of require you to buy into the whole thing.
It's smaller. It's way smaller than.
Yeah, I mean, I have no problem with jQuery. And again, I have no problem with React if it's used in a good performance-oriented way. But I don't feel like the Next.jses of the world are providing a good minimum baseline to do that.
I think there's also been kind of a lot of shift, or I would say really interesting discussion happening in the JavaScript world in terms of what we're going to do with our architecture. On the one hand, 4 or 5 years ago, Jamstack, big like Jamstack, like this is the future. We're moving towards Jamstack. Now it seems like it has shifted to composable architecture, right? Jamstack, like I think that the Discord channel for Jamstack was closed. So where are we actually in that space? Like, I mean, you especially like looking at the static site generator like 11, right? Where do you feel we actually are in that space? And
yeah,
and how does it actually fit within the larger landscape of what we have in front end?
Yeah, I mean, I think Jamstack was a useful term that organized a community. And I would almost give the same question or the same answer to the PHP question that we just talked about. If a Jamstack style application is working for you, great. There's no problem with that. I think that Jamstack generally had the same problem that single-page applications sort of went through. When you have a static page by default, you almost need JavaScript to develop interactivity, to deliver interactivity to end users. And so you're sort of caught between a rock and a hard place where you have a static page, but you need more dynamic content. And the only way to do that with the Jamstack historically was using client-side JavaScript. So I think that is changing a little bit, but as we get more tightly coupled to Jamstack providers, I think that introduces another risk that you can talk to me about later in the hallway.
Yeah. I think just 2 more questions, and then we'll wrap up. They're very similar, actually. When you look at the state of front-end tooling, like when we look at React, we look at Vue, we look at Angular, and so on and so forth, what would you say is the most important missing bit? Because again, we are getting better in some way, but it's also like the bundle keeps growing, and it's actually really makes it much more difficult for people who just want to enter that space to even make sense of it. So what is missing in that area? What do you think?
Yeah, I think we need more meta frameworks that are HTML first, and I don't think. I mean, there are a couple that exist today, and I talked about some of them in my talk. And yeah, I think we just need more competition in the HTML first space because it really was just really a crowded competition competing for single-page applications. So everybody wanted to win the JavaScript controls the entire lifecycle of your page use case. And it left out sort of the document style or the more classic, like I want to develop HTML first, developer mindset. So I think that is changing. Again, the pendulum's swinging back the other way. And yeah, that's been great to see.
Yeah, but I think there is also quite a bit of heated debate, I would say, between people who would say, well, there is nothing bad with JavaScript. Right? Let's just go JavaScript and embrace the complexity of the web and the world as it is. Yeah. All these people who claim HTML first and all, let's just go JavaScript first. Yeah. It's okay.
Yeah, and those people are testing their applications on their $1,500 iPhone or their $3,000 MacBook sitting on a fiber connection. So when they say it works great, they mean it works great on my machine, on my connection. And to me, it's very communicative of their bias not expanding wide enough. And we need to, think about an entire worldwide of experiences. It's just, there's a wild world out there of so many people that do not have the best hardware and do not have the best internet connection. And they should be included on the web too.
Yeah, I think that in many ways, what I argue against that is that basically when you go JavaScript first, in many ways you're excluding first. And then you bring people in who happen to have a good connection and with everything, right? So I mean, the decisions we're making in terms of front end, they have massive implications on the world around us as well.
And that will show up in your metrics too, right? Because the people that don't visit your website are not really reflected.
Yeah. And then, I know we're running out of time, but the final question from Paul. Well, we kind of answered it partially. Why are web components not mainstream yet? And do you expect them to become a mainstream within the next couple of years?
No. I don't think that web components will ever be sort of the primary development model because the existing abstractions that live on top of them are really the correct, are really the most popular mechanism that people will enter component-based development. So I think that there will be more libraries that crop up that sort of abstract away web components for you. But I think we'll continue to see component frameworks that sort of go off on their own way and are doing their own thing. Because again, the main benefit to using a component framework is that it can iterate faster. The platform moves slower. And that's just a part of the game that we're playing. When you need to implement something in multiple web browsers, it just takes longer. But there can be an incredible long-term benefit to buying into the platform and waiting for the platform to catch up to sort of current models, and buying into little pieces of it as it increases adoption. So yeah, I think that we'll probably continue to see more and more component frameworks that are web components and not web components.
Okay, well, I'm very much excited to see what the future will bring. Well, thank you so much for being with us, Zach.
Yeah, thank you for having me.